So hello everyone and welcome to our presentation AI for Digital Engineering, and we are really exciting to show you some research results of the research project called ITOC, and maybe some few words also for ICAS INTEC. So we are a solution provider for digital twins and virtual commissioning. So we are developing our own software, and we are using this software, and we are going in the direction of simulation. So our understanding of digital twin is simulation, so behavior simulation, 3D simulation, material flow simulation, and so on. Yeah, and I will give first the word to Miriam, and she will explain the vision of our research project, ITOC.
Thank you, Dimitri. And as Dimitri said, I will just introduce the project itself, because it's one of our research projects. It's a European funded project. This means that we are working with partners together from all over Europe there. And the vision is we are in the context of plant engineering. So this means that we have the engineering of plants. And if we look into the nature of this process, of this production planning of the production plant, the first thing you will recognize is that you have a bunch of people there. So you have different disciplines, you have different knowledge, you have different people who have to collaborate, because it's not that one person is planning a whole production plant or production line, but you have a lot of different disciplines like mechanical engineering, electrical engineering, the PLC programming, the robot programming, and all these are building some production system together. And this means that you have a lot of different steps which have to be taken until the factory is running or is in operation in the end. And this is one thing, you have a lot of software tools who which support this process, because it's so complex what we do in our factories that not everyone can understand everything there, that you need some software support, and we are really extensively using software there. And the vision of the ITOC project is that we have the digitalized, automated and AI-supported manufacturing engineering, and that in all phases. So this means that we investigate during that project where AI can help and where maybe AI is not the right thing to support this process. And we had already some examples where AI didn't fit, but we also have one example where, at least from our point of view, it really fits very well, and this is what we will explain right now. And this means that we are caring about the operation in the real factory. Like Olaf already mentioned, this is signal-based, so this means you have some machines, you have some robots, for example, and how you put those things together is that you're monitoring the signals, you're sensing, you're acting, just like if you would have some human with his senses, with his or her actions, and all that is digitalized. So this means that we have some visualization, we have some simulation, we have some emulation even before the factory is in operation, and there are different possibilities how to support this. One thing is that maybe you can use AI to support layout generation, because you have different alternatives which have to be investigated. You can use AI for the production and equipment model generation, because you need models to have a simulation. You need to have a representation of the real thing before it is there in practice. And we have the AI-supported processes, planning and instruction generation. So these are three different things we are looking into, and as you can see on the right side, we have a lot of different standards. So our problem is not that we don't have any standard, but we have too much, in fact. And some of them are extensively used in the ITOC context, so in the project context. Some of them are really state-of-the-art in our factories, but some of them are quite new, like the FMI standard, and we will see that later on. This FMI thing is some kind of black box simulation, which is really not tool proprietary, but standard-based. So this means you can put your models inside this black box. You can have a co-simulator which makes it possible to run those models. And this is really one key factor that you do not have to build 5 different simulation models, but you build one for example, from a component vendor point of view. And after that, you use it in different tools. And all the tools support the standard, at least in the discrete, factories. So, for example, in automotive context, it's really some kind of upcoming new thing. And nevertheless, it's really some cool idea, which was there already years ago, which was also developed in some research project in the beginning. But we will see how we can use it and also how we can combine that with AI.
Yeah, and in the next slides, we will focusing mostly on this part here. So the AI-supported production equipment model generation. And here you have a concept of the approach and the solutions. So what we want to do is we want to use real measurements from sensors or cameras and so on, and to derive out of that some behavior simulation, some behavior what we can use in our environment, then later on to bring that in as a digital twin or in the virtual commissioning. Yeah? And what do we need for that? So first of all, we have our components. It can be industrial robots, it can be pneumatic cylinders, it can be frequency converter. So in our demonstrator later on, we are talking about the frequency converter, and it is used for controlling an electric drive. Yeah. So in our case, it's used for turning tables to bring some product in a right position, for example. And we use that because it has it's difficult to make a behavior simulation out of it, because there's a lot of logic what you have to implement there. And usually the guy who bring a digital twin together is not that expert in the devices. So as a frequency converter is really complex, and he has a lot of manual effort to bring this knowledge from technical data in a behavior simulation. So, and as you can see, you have different possibilities to get the data. So you can directly connect to the sensors and use the data from the sensors. You can also use simulation as synthetic data to use it later on, or you connect to the controllers, and this is how we will do that, and take the data directly from the controller. Yeah. And what are the next steps? So we have different parts here. So we go at least to the AI expert. So we have a part for preparing. So this is the pre-processing part. So you have to bring the data in a form that you can use it later on for the training. Yeah. And then you have the training itself. You have to validate your models, and this is the validation with given data, and then you can export, or you have to export this AI model, which can be executed by AI tools, but not for simulation tools. You have to export it in a proper format, as Miriam already mentioned, the FMI standard we used here, because this standard we can also use in our environment. Yeah, and all of these, we want to bring it on one platform with in a modular way, where you can exchange the modules for pre-processing. Depending on your data, you have to use different pre-processing models, or also for training models. And in the next video, I want to show you the first prototype, how we implement these pipelines for AI use. And it will be really fast, but I will say some words, and after the presentation you can also ask. Yeah? So first of all, we have the possibility to load a pipeline, so something what you pre-configured, for example. You have here modules which import data. In this case it's CSV importer, and always when you import the data you can see also the inputs, outputs, and here you have a table viewer where you can also see the values of your data. As you see, you have Boolean values here, you also have continuous data here. And all kind of these ones you have to pre-process on a different way. So, and here you can really connect the modules with other modules by edges, yeah, and bring that in right form. Yeah, it's a little bit slow. Yeah, but doesn't matter. Okay, and here you can also load some pre-configured part. Yeah, you don't have to do that always manually, and on the right side you see it's a prepared training module. Yeah. You also have the possibility to make some configurations here in the training model. For example, you can choose the training epochs, or you can also configure the training rate, learning rate. And one major point here is also you can use feature of the pipeline is that you can also visualize your signals. If you want to have a deeper insight, you can see it will plot the signal, and we don't have to do that in the beginning. We can also do it in a later stage where you can see, okay, now I prepared my data. Is it now on a proper way how I want to have it? If you want to have a deeper insight, you can also zoom on it. So, and here you can, the good thing here is the inner parts, so the controller and also the module templates are open source. So the idea is that everyone can implement modules here. Yeah? And not everyone is expert in every part here. That's the reason you can implement here training modules for another company, and you have different business models what you can prepare here. And now you see, now we connected everything, and now we are running the training model. And now we have the possibility to execute it. So currently it's on the platform. It's used, here's used TensorFlow, and but you can directly evaluate that in form of prediction and expected results. And as you see, for these two signals, it's quite the same. So, but this was the first analysis here.
Yeah, now that we have seen how this works in practice, we like to tell a little story about it so that you can maybe just deep dive with us. And maybe you know once upon a time, if you're old enough. But we really like that. So we will now do a deep dive into the data, into our factory, and into this AI pipeline. So this means that we will start with our little boy, poor little old boy, who starts by generating our data. So we are focusing on several modules. So this means in this example, which we have right now, we are focusing on behavior models.
Yeah, as I already mentioned, your data is different from each other. So you can have continuous data, you can have Boolean data, you can have camera data, you can also have audio data, and you have to bring that in different pre-processing pipelines. And
once you have this pre-processing, you first start with the classification. So you divide your data into, for example, numerical, Boolean, and categorical data, so that you can process it afterwards in the right way, depending on the nature of the data.
Yeah, in the next step, it's maybe we have to do some anomaly detection. So we are talking here about real data. So you have sometimes some measuring errors or some voltage peaks. And here you have different methods, for example, clustering, where you can filter out the anomalies and bring them out, because it could influence also the behavior after training.
And after we've filtered out the anomaly detection, you have to keep in mind that we have the whole recording of the data which is occurring in, for example, a factory. So this means that we are focusing on components, but this means that not everything we have in the data is really contributing to the most significant things. So this is why we do a feature, or we select the important features which contribute to the main actions of the component, which contribute to the main things which happen. And this is one thing which you also have to keep in mind if we are talking about behavior model learning, and if we are talking about components in the factory, these components are controlled by PLCs. We are recording these PLC signals, and the logic inside the PLC is some really deterministic thing. So you might have some changes at the time slots when signals come, but in general the behavior is predefined. So you have different things which happen and which are from PLC side towards the mechanical parts or the frequency converter. They are really deterministic.
Okay. Now the data is pre-processed. Now we start the training. Yeah. As you can see, we have here Mr. AI, and he's going to the gym and start the training. Yeah. And it is like in the gym. So if you are train your model in the gym, so don't make him to a good climber, for example. Yeah. Yeah. And also maybe he have to do some squats for the legs. Yeah. But it's. For this case, it's enough for training our model, yeah? Because we want to have a model to doing exactly that what he's training for, yeah. But if we are talking about a frequency converter, so we have data where we use the automatic mode, and we collect 8 hours of signals in a 50 millisecond slots. And what we don't have it inside is, for example, the manual mode, so jog mode, where you can rotate also the turning table in this mode. And it's not trained for that, and it's not validated up till now, but I think it will be not possible to use it. But maybe our training module there was some magic and it's possible, but it's important to understand you need the right data for and the right method for your what you want to have on the end in your model. Yeah.
Yeah, now that Mr. AI has trained enough, he has to bring that to the finish line. So this means that he has to decide whether some of the possible standards or things how you can use those models fits to him. So this means in our case, like we have already mentioned, we will use the FMI standard, which is called Functional Mockup Interface. And Mr. AI pulls on his FMI shirt right now.
Yeah, and in the next part you have to export this FMI AI model in a proper way. So we have trained it, for example, with TensorFlow. You have your TensorFlow model, which is executable with TensorFlow, and here you can use this FMI standard as an interface. Yeah? So the FMI standard will surround this model, and our environment can execute them. And the FMU, it's really close. But it has inside all the dependencies what it needs for execution of a TensorFlow model, for example. And here, this is main work for the FMU exporter.
And now that it's exported, we are coming to the point where we can make use of what we built. So this means that we have now this functional mock-up unit of for example, one component, but you want to use it. So this means that Mr. AI is now thinking about the component and using it. And as we do not have only one component in the production system, for sure we have to learn different models. We can combine even white and these black box models. So this means that we can combine predefined simulation models with that one. And there is currently, it's even evolving, but there is a lot of support of the standard and integrated co-simulators in most of the simulation and also virtual commissioning tools, which are currently used in industry. And somehow, so we are really addicted to the standard because it brings us really a lot of advantages. And we can see that during the last years, also all the big players, for example, in the automotive industry, made the same experience.
Okay, as Miriam already mentioned at the beginning, so manufacturing is not only the planning of the resources or the behavior simulation. So in iTalk we also talk or work on block layout, or so we try to use AI also in the support of the layout development, and also parts like process plan, where human simulation is one big point here. And yeah, this is what we want to bring in this research project. So we talk about the whole life cycle here from a plant, where we find out where it's useful to use AI to support the engineers and all the planners. Yeah. And here I say thank you for listening, and if you have questions, please.